So today we're going to talk about how waves interact when they meet each other and why they interact in these particular ways. Before we do that, we need to discuss two concepts about waves. The first is something called the phase difference. So let's say I had this wave. Now you can think about phase difference as basically the angle between different points on the wave. So from your maths course, you can clearly see that this has the shape of a sine wave. And you know from a sine wave, if this x-axis was in degrees, this would be 0 degrees, 90 degrees, 180, 270, and 360. But there's also a different way to measure angles, and this is through a unit called radians. And how radians are related to degrees is that pi radians is equal to 180 degrees. So if I were to relabel the angles on this wave using radians instead of degrees, this would be pi over 2, this would be pi, 3 pi over 2, and 2 pi. Now when you're talking about phase difference, they primarily use radians as the angle, but they can also use degrees. So if I ask what is the phase difference between, let's say, points 1 and 3, we can clearly see that it's pi over 2 minus 0. So the phase difference between 1 and 3 is equal to pi over 2. And you could do that by every point. Let's say I said that between 1 and 5. Well, that's equal to pi. Between 1 and 7 is 3 pi over 2. And between 1 and 9, it's 2 pi. Notice, however, because this wave is just a continuous wave, so it will continue going, this 2 pi point is also equal to the 0 point. So this could also have a phase difference of 0. 2 pi, having a phase difference of 2 pi and 0 is the same thing. Now when the phase difference between waves are either pi radians or 2 pi radians, we can give them a special term. When the phase difference is pi radians, we can say that they are completely out of phase, or we can say that they are in antiphase. And when they have a phase difference of 2 pi or 0, we can say that they are in phase. Now the thing you have to remember about this is that phase difference is basically measured as an angle. And now there's another concept that you have to know about, which is called path difference. Path difference is the difference in the distance measured, but this time it's in terms of the wavelength of that wave. So let's say I had 2 points, A and B, and they both emit exactly the same type of wave. That means that they have the same frequency and the same wavelength, and we'll call this wavelength lambda. And they meet at this point I'm going to call M. And granted, this drawing is not very good, but you can see that the number of wavelengths traveled by this black wave when it reaches this point is 2. So you can say that distance traveled by the black wave is 2 lambda. And the distance traveled by the red wave is also 2 lambda. So the path difference between these waves is equal to 2 lambda minus 2 lambda, which is just equal to 0. Now let's say I move that point to this point here. And if we do the same thing, how far has this black wave traveled? Well, you can see in this case that there's been two lots of wavelengths. So we can say that the distance traveled by the black wave is 2 lambda. But if you look at the red wave, you can see, well, there's been 1, 2, 3.5 wavelengths traveled. So you can say that there's been 3.5 lambda as the distance traveled by the red wave. So this time, if you work out the path difference, well, it's 3.5 lambda minus 2 lambda. So the path difference in this case is equal to 1.5 lambda. Now in this final case, you can see that the distance traveled by the black wave is 2 lambda, and the distance traveled by the red wave is 3 lambda. So the path difference in this case is equal to lambda. So we can say that the path difference is the difference in the distance traveled by the waves in terms of lambda, or in terms of the wavelength. So why is this important? So let's see what happens when two waves meet. Well, when waves meet in phase, and this means that the phase difference between the waves, if you remember, is 2 pi. Or when they meet with a path difference of n lambda, where n is an integer. So that means that the path difference is a whole number of wavelengths. They constructively interfere to form a maxima. And let's see what an example of this could be. So let's say I have these two waves which are in phase. When they meet, they constructively interfere. So in this case, the amplitudes add together. So the resultant wave, due to the fact that these two waves have met, looks like this. The amplitudes of the black and the red waves get added together to form the green wave. This is an example of constructive interference. Now, as you can guess, the opposite of constructive interference is going to be destructive interference. So, when waves meet, this time in antiphase, and remember that means that they have a phase difference of pi radians, or when they meet with a path difference of n plus a half lambda, where n is an integer, the waves will destructively interfere, and they will form a minima. Now this formula here might look confusing, but all that is saying that every half lambda there is going to be destructive interference. So when the path difference is a half lambda or 1.5 lambda, 2.5, 3.5, 4.5, and so on, they will destructively interfere. Now here's an example of what destructive interference could look like. You have this black and red wave that are out of phase, and when they meet, they're going to form this green wave here, which you can see has zero amplitude at every point along the wave. So in a general case, when you're asked to describe how constructive and destructive interference take place and when they take place, you can say that when waves meet or interfere in phase, which means they have a phase difference of 2 pi, they will constructively interfere, hence will form a maxima. When they meet in antiphase, or when they meet completely out of phase, which is a phase difference of pi, they will destructively interfere. And that way they will form a minima. So in general, when certain waves meet, you can get a series of maxima and minima due to constructive and destructive interference taking place at different points. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.